All good?
Yep.
Awesome. So, what exactly is the cloud? It's where you send your data and your compute, and they send you a bill. Realistically, it's somebody else's computer. I mean, we all know what a data center is and what a cloud vendor is. That's not particularly exciting. But the reason people really like the cloud is it lets you just turn capital expenses into operating expenses. You don't have to do data center procurement or maintain a physical presence. The finance people like it because big spiky purchases are always a pain in the ass. And if you just get a monthly bill, that's a lot cleaner. And also, it is just one bill. You're not dealing with Dell and your colo and your ops people and whatever else. But there's a lot more concerns than just moving something to the cloud, because you can move stuff to the cloud very easily. They call it lift and shift, and it's literally, let's just take all the servers that we had already and then just pay lots of money to run the same software we were running on VMware, NRDC, on EC2. And really, when it comes to understanding what you're doing in the cloud, I want to make a distinction between sort of these foundational primitives that a lot of vendors offer and the more, I guess I would say, managed stuff. In the context of AWS, I'm just going to talk about things you need to know to really understand how the heck all the infrastructure works before you can get to all the different services that they have and thinking about those. So really at the core of AWS is IAM, or Identity and Access Management, and that's a bunch of stuff that just goes into who is allowed to do what and spend what money. So IAM policies are actually a really terrible nightmare to understand because there's like 10 different things that all interact with each other. But at the foundation of it, and for most vendors, you're really going to have this idea of users are people or machine identities, and they're allowed to do things. They usually have roles attached with them. I know GCP is different.
Yes, well, I'm not saying it.
And so roles usually just define, okay, what are the policies that define what a user can do? Or actually not really a user, a role. It's really best to just think about most cloud things in terms of like, here is a role. Like there's a role that allows you to create virtual machines or put things into object storage. Or on the flip side of that, you can have a role that says, you're not allowed to do these things. Like, you are not allowed to create new users, which is probably a very good thing to have on most of your users, because you don't want somebody else to be able to say, hey, I can't do this, but I can create another person who can do this, and just assume their identity. And then resources are just all the things in the cloud. If you think about it, everything is really a resource that can be acted on. You could do a whole talk on AWS IAM. So I'm just going to skip past most of the intricacies there. You've got your networking, and that's really just, don't really think of cloud networking as like your home network. Yes, there is an IP range for most of your things. Yes, it looks a lot like the kind of on-prem network you would think about, but it's really not. It is just this logical abstraction over the terrifying things that cloud vendors actually do to move your packets around. But on top of that, most things you're going to be doing are going to be in a virtual private cloud, which is basically just a VLAN for your stuff. They usually divide stuff out into subnets. So, okay, here's this IP space. It could be public, it could be private. On all of these, you usually have to go and set up some kind of like gateway that lets it, talk to the internet natted for private subnets, so you can't get internet traffic, or just through an internet gateway, which lets public internet traffic reach your IPs. And they also have this thing called a transit gateway, which is really just for the people who want to have an on-prem presence still. And it basically serves as a big VPN between AWS and your data center. Okay, that's not too exciting. So on top of all those things, which are really, really foundational. I would say most cloud services you can divide up into either providing you like data and storage or providing you with compute. So everybody knows what S3 is. It's really...
Who knows what S3 is?
Who doesn't know what S3 is, actually? Cool.
I don't know what S3 is. Please explain S3.
So S3 is object storage. It means it is a big, essentially key value store, not like Redis exactly. It's durable. You basically just have what they call a bucket, but it's just a long string prefix, and your data lives at that. It looks a lot like a file system. It's not, except when it is when you're using the new S3 first-party file system mount that they just came out with.
What about S3 lifecycles?
That's not really germane to this.
Okay.
But I can talk about those later.
Okay.
That is kind of on the saving money side. And they also give you kind of managed databases. So a lot of cloud things are kind of a spectrum from doing it all yourself to letting them handle everything for you. So on Amazon, you have RDS, which is, I think, relational database service. And that is like, we'll just host Postgres or MySQL for you. Or MySQL Server, and you can like bring your own license or pay for a license. So sort of your traditional SQL databases. They also do a lot of stuff. It's like DynamoDB, which is just a, if you're familiar with Mongo, it's a NoSQL database. It's like, you've got a key, and at that key, you can put whatever the hell you want at it. And so that is on the serverless side of things, where you are basically paying for usage versus paying upfront for some amount of capacity. And then you've got compute. So EC2, like that's pretty much a VM. If you've ever spun up a VM anywhere, you really kind of understand it. Cloud providers love making extra ways to run containers. There are so many ways to run containers, but so there's ECS, which is like Kubernetes Lite, EKS, which is just, we'll manage Kubernetes for you. And that's sort of a cattle, not pets approach, where instead of like having a server like you would in your data center, you just have a fleet of things and you don't really care about the particular instances of them. You should be able to just kill one and have it come right back up through some sort of scaling policy. And then really the value add or way to waste tons and tons of money is serverless, which really just means on top of the cloud vendor taking care of all your infrastructure, they'll take care of the logical parts of it too. So you don't have to worry about like, okay, what runs on this VM? You just run your workload. There's Lambda, which is really cool. It's basically saying, we'll just run this little snippet of code and bill you by the millisecond for it. ECS on Fargate, which is just like kind of Kubernetes Lite, except you don't have to worry about VMs on that. And EKS is on there twice because they have a serverless, well, managed EKS basically. So, let y'all get seated.
This is a very good slide. AWS is not going to give you this slide, but point 3 is important.
Okay, sorry. Now that I've just listed the kind of things that exist in the cloud, this is what I really wanted to talk about. So with those primitives, you can go a very long way in building any kind of application you want. So, for example, let's say you want to have like Elasticache. Well, you can put it on an EC2 instance. You can put it in Kubernetes. You can put it in ECS. You can also use whatever the AWS managed version of it is. And the reason a lot of these exist is because it's a good way to get a promotion.
That's more money. Hell yeah.
Not for you, though. For whoever was the project manager.
Yeah, you're getting a promotion by putting on Kubernetes on the last slide if you're an engineer. Your boss is getting a promotion for this.
Yeah. Your boss or whoever thought it was a good idea to make a new service at AWS. Because they will let you build anything you want on top of their platform, but they will also offer you managed versions of like literally everything where they do the heavy lifting. And this is really dependent on, how much effort are you willing to spend managing these services versus how much money are you willing to spend to not have to manage these. So, that's my first line. Do what works for you. It is very tempting to just say, okay, well, this thing gives me cross availability zone backups and I don't have to worry about it. And, it's just done and dusted. But how much more are you spending on it versus developer time? Like, if this is something that could just live as a sidecar in Kubernetes, maybe that's the way to go. And really your best bet when it comes to these things is just actually profile your workloads and ask yourself, is this something that's going to be very foundational to what we're doing? Do we need that much availability? And if our main application goes down, does it matter that our managed service will fall back to another region? Or another AZ. There is cross-region stuff, but I'm not going to get into that. And some of these are actually really good. Like Aurora RDS, it was basically AWS. They took Postgres or MySQL, wrapped it up in a layer of their own, and they'll deal with all the backups and replication for you. Excellent. Actually cheaper than vanilla RDS, depending on your workloads. Totally would recommend. Some of these things, I swear to God, really do just exist because somebody needed to make some impact and push out a new service. There's like 200 AWS services now, if that gives you any idea of the scale of these things. So if you're looking at a managed service and you think, oh, this looks nice, actually go look at the pricing and put that shit in Excel. Because you might find that by the time all the cross-AZ data transfer cost and the sort of managed cost add up, it's just not worth it for you. Although you also have to balance that with, do we have somebody who can manage this? Or do we just roll in the cost of this as this is basically just equivalent to some FTE salary? I guess not really good for DBAs, but it turns out you still need them anyways. Now they're just good at managing AWS too. Yeah, so it's all trade-offs. Your time is money. Your money is also time. And the thing is, you have to find the point that works for you where you're not spending lots and lots of money to save a little bit of time. And AWS is not a magic bullet for these kind of things. Like, even if you do, or even if you don't have to worry about the infrastructure portions, you still have to have domain expertise into the services you're running. Like, they'll take care of handling lots of Elasticache stuff, but you still have to have somebody who knows how to design the goddamn thing. So, yeah. I definitely yapped about this one a little more before I got to this slide. If you want to actually learn on AWS, there's two really nice things. Gary told me about MiniStack, which is a replacement for LocalStack, which just tries to replicate as much of the AWS surface of services on your machine. So you can just download it and run it as a Docker container and play with the APIs there. And they also have the free tier, most cloud vendors do. Although,
what is running in a Docker container and scoping?
MiniStack.
Does that emulate data that's running, or does it just make API calls too?
It emulates it. Just the API calls though. I don't think it actually does the console for you. So if you're using like their CLI, you can basically just point the endpoint at the MiniStack instance that's running locally, and then play with that. So if you wanted to say like, oh, here's a S3 integration, but I don't actually want to stand up an account yet, you can just have it make calls against your container instead.
Okay, so you point the actual AWS CLI at MiniStack?
Yeah.
Okay, yeah.
And then, So they have a free tier now that's actually free. It used to be there was a free tier and they just wouldn't charge you for services up to some limit, and if you wanted to spend money you could just still blow your foot off. But they've changed that, so it's basically a limited kind of account, and if you go over that it'll just stop working. So great way to avoid getting like $1,000 bill.
Oh, I didn't know that.
Yeah, I think that was actually relatively new. I'm very excited about it though. That used to be probably the hardest part of getting experience of any cloud vendor, is knowing like what is actually going to cost you money. Because so many things are free right up until they aren't.
And then it's $40,000.
Mm-hmm. Oh, sorry.
No, it was just like I finally saw IOC. I'm just like there.
Okay, so if you're new to cloud dev, or if you are, even if you aren't, one of the things you're going to be really tempted to do is just go click around to the console, go make some resources, play around and see what you can spin up. Don't do that. Well, you can, but don't do that outside of a dev account. It's really easy to just make a lot of things that rapidly get out of control if you're just doing ClickOps. And that's, just, let's just go into a console, make some instances, attach a policy to it. So what you end up with is so many things that just aren't really legible or formalized anywhere. And then you don't know what's in your account, and then now you have something in Asia Pacific 3, even though you're in America. So use infrastructure as code. All of these are really good options. CloudFormation is specific to AWS. It's pretty nice. You end up just raw dogging a lot of YAML if you do it this way. I have been slowly trying to convert things to using the CDK, which is, they did everything as TypeScript, so now you can have your infrastructure as Turing complete code, for better or worse. You can run for loops in that shit. It's fun. And then there's always Terraform, which is just another vendor. They take care of the tricky bits for you. And the nice part about Terraform is once you've learned it, you can use it across lots and lots of services, because everything will have the same format, and they'll have a provider for AWS and a provider for GCP, and apparently they have a provider for like MikroTik routers, which I found out trying to set mine up. So.
Or for Kubernetes cluster.
Yeah.
Really?
Yeah.
Ah.
Have you tried OpenTofu?
I have. That's actually what I use.
So instead of a YAML, you get the Terraform?
Yeah, you can.
Yeah, it's like the Terraform DSL. Yeah. Mm-hmm.
What's your problem with YAML?
It's just a really bad language for configuration, because it's very like imprecise, and there's a lot of constructs that like look like strings and aren't. So there's a strict subset of YAML that makes this a lot easier to use. Also, I mean, you're really just like writing text files without good, IDE support. And when you're doing any kind of cloud dev, it's really helpful to have some kind of autocomplete, because every service is going to have slightly different naming conventions and capitalization, and it will just drive you crazy. And so on the Terraform side, they take a lot of that out. So things that could be like, cased slightly different or named differently, typically provider is like just a bunch of Terraform modules per a particular thing. They'll do some extra work for that.
So does Terraform use what's called HCL?
Yeah. It's a JSON-looking syntax.
HashiCorp language.
Yep.
So
Or OpenTofu.
Would you just use OpenTofu today?
Yeah.
Okay.
HashiCorp is not so good. They used to be a really cool company, but we've kind of been going to some vendor lock-in. And, oh wow, that was a lot blurrier on here. But I was really looking for this picture for a while. So if you're wondering what's on here, this is how you turn on a light bulb using the cloud. This is from Philip's Hue GCP talk.
This is the slides and how our architecture looks, but it really just says, this makes me look smart.
Yeah, yeah. And it is very tempting to do stuff like this. I mean, I understand this is like at a very large scale, but if you go to any cloud vendor, I think AWS calls it well architected, but they have a lot of example frameworks for how you should do things. And they're usually good, somewhat robust, but all of them have the same thing in that if you do those things their way, they will cost you lots of money for not a super great gain in reliability.
You know, this is actually who turn on the lights to AWS.
GCP, but yeah.
From a phone app,
Mm-hmm.
Awesome.
That'll turn on lights from your phone.
where everything goes through the cloud. What's on the right side of the screen?
That-
See Datadog?
Oh yeah, that's just their monitoring.
That's monitoring.
Mm-hmm.
What's above monitoring?
I don't actually know.
What would Elasticsearch be?
Kubernetes containers, or what do you think the blue hexagons are?
Search for the white light turn on?
You know, I don't actually know all the GCP symbols, unfortunately.
Yeah, Smart Portal, I don't know.
I see Elasticsearch in the
Mhm.
vertical.
That might be Google App Engine or something. I'm not actually sure what's going on there. Stackdriver is just an old name for the internal.
Wait, what does Redis do?
Monitoring on GCP.
Well,
Are we looking too much into this?
Probably, but
well, I like that the light bulb has a single point of failure to turn on and off, which is Redis.
yeah.
Well, everything is, yeah, it doesn't seem like a,
It does seem like an Amazon approved design.
Yeah, definitely a vendor-approved design.
You won't be able to adjust your lights without this load bearing
Exactly.
in the middle, it looks like.
you know, I think a switch might be more reliable.
A light switch?
Or like a network.
No.
Whatever happened to clamp on top of?
You know, if it's not an US East one, how are you going to get high availability for your lights?
What if I happen to be in Asia too?
Well, then you just use whatever the
It might-
outpost is
There
there.
might be a delay if your lights are not in Asia.
I guess this is kind of the opposite side of going all in on cloud services is,
Setting up a clapper for your lights?
yeah. But no, I mean, really the takeaway from this is if you are doing anything, just profile what your usage is actually going to be and how much it's going to cost you. Don't overcommit to doing things the cloud way. You know, it might save you a lot of money. And the thing is, with serverless, there is a bit of a curve where at really low traffic, it's basically free. So you could go and you could run a Lambda function and an API gateway and spend 0 or fractions of a penny for your application. But as these things scale up to high load, there is a point where it rapidly gets more expensive. And that's just due to a lot of the cloud pricing model, which is we'll charge you for usage and we'll charge you higher amounts for some amount of capacity up front. I guess I would use the example of maybe electricity, you know, you could get metered for some amount of usage, or you could probably have some deal that says, hey, we'll provide you, basically a pipe with so many kilowatt hours, and you either use it or don't, but you're paying for all of it if you need it. So always, always, always go look at the pricing and ask yourself, well, also, is this a realistic load for my app too? Because if you have something that has very spiky loads, serverless might be for you. If not, maybe you need something that just runs all day and it's fine. Yeah, so if anybody has like specific cloud questions, I would really love that. Yeah, go ahead.
What's the best use case for a serverless function?
When you need to do something with a really small, well-defined scope, and it has a low runtime. So serverless is probably the best when you can say, hey, maybe read from an event stream. Like if you're processing images to resize them, you say, okay, somebody uploaded an image to S3, that puts out an event, your Lambda goes and gets it, and it crops it, or it just standardizes it.
Creates a thumbnail for it.
Yeah, thumbnail creation, that kind of thing. Depending on your amount of traffic, they're actually pretty good for APIs. If you're on the low side, like I said, you can spend like $1 a month and have a pretty sizable amount. The thing though with serverless is you don't want to be leaving any of these things running because you get charged by like the gigabyte second. Some of these pricing metrics get into that kind of thing where it's like there's capacity and there's time. So really always think about it in terms of, just money over time.
Would you ever use it to update it, like a database? Like if someone submits something on your site, would that be, or would you use something else?
So if you have like a static site and it's just an API where somebody can submit a form, that's actually a really great use case. If you've ever been to Code Until Dawn, the QR code they have at the door is actually just in a little Lambda.
So it opens up a web page and on submit, it hits a Lambda and then gets sorted somewhere magically.
Pretty much, yeah.
So I know something like Terraform versus CloudFormation is meant to be more cloud agnostic, but what are some common problems you have when your, higher ups tell you you have a month to change the cloud provider because they're trying to save money?
That's stupid. Well, you probably can't say that, but if you're trying to do multi-cloud, it's usually a dumb idea. You're going to get better discounts if you commit to some amount of spend on a particular vendor versus saying, oh, we'll just hedge our bets by doing a shitty job on 3 cloud vendors instead of doing a good job on one. As far as your higher ups goes, I really haven't ran into that problem myself. We're all in on AWS, but yeah, I think that is the thing. Unless there is some feature that a particular platform provides that is way better than the others, maybe like Cloud Spanner or BigQuery.
Lower egress if you're serving videos.
That too, yeah. And I mean, you can definitely combine these things, but just from a pure economics perspective, I don't think it's ever going to be cheaper because you are going to get hit with egress between all of these things so much.
Note that you'll also get hit with egress just going in between regions within the same cloud. Usually about half the price though.
What's the largest bill you've accidentally run up?
The largest bill I've accidentally run up, we usually run pretty lean, so it would probably just be in the couple thousands. And yeah. And that was really just because we had a database going to extended support where they charge you lots of money because you didn't upgrade.
Oh, okay. What about you?
Fargate services crashing and upon crashing constantly refreshing or attempting to re-download their image from the container registry over public internet. Charged in gigabyte seconds.
Oh no.
Yeah, that was. Someone didn't notice that for about 20 days. I was only kind of secondarily involved in that, but that was about $18,000.
Holy shit, that's
Did
crazy.
you get it wiped?
I don't think so, no.
Oh,
It was someone else's problem,
Oh yeah.
I didn't know the appeal process on it. I wanted to make sure that didn't happen again.
So wait, how are you getting charged for that? Was it like egress fees from
Yeah,
ECR?
it shows up on their compute, on their EC2 actually, even though there was no EC2 involved in the Fargate,
Oh yeah.
With AWS, what are like some of the global problems that are outside your control? In other words, If you build a well-architected process, you wake up one morning, it's down, and it's down for reasons outside your control, what could those reasons be?
Falling object. So, random falling object from Iran.
Oh, I mean, but yeah, but still going more.
Actually, so with cloud vendors, I take the approach that if like US East 1 is down, you are having larger problems.
Yeah.
Just recently, last 6 months, AWS and Azure were both hit with DNS issues within weeks of each other.
That's right. I remember the observer.
Oh yeah.
Is well beyond any scope you can do in here.
Yes.
The only people that survived were the multi-clouds that were able to route around until the services came back up.
Although that wouldn't happen if they both went down at the same time.
Although you kind of get an accountability sink in that people will just understand that because these things are so foundational to so many applications in the internet now, like everybody is having problems and it's not just you. So it's
It is an Oracle Cloud.
You should really, it's good to know, like, okay, yeah, an act of God could always happen, but we're on gold news that act of God is going to probably be a hurricane. But no, it's good to know those categories.
Oh yeah. So you definitely get a bit of an accountability sink there. I mean, you do still have to be responsible for securing and maintaining your infrastructure. It's not totally free in that regard.
And what kind of recovery time objective is business willing to pay for?
Yeah. Are you a bank that if you go down, you lose like millions in transactions every second?
Yeah.
Or do you serve funny monkey videos? Like
Exactly. And the thing is, it's probably possible to beat AWS on uptime in a data center. I mean, you're probably not going to beat them on like durability for storage for stuff like S3, but they run into, it's like they're very big and they're doing a lot of things and that are very interconnected. So if you have some particular workload and are on top of it, you can totally beat the big boys for keeping your service up. I mean, you're not at the same scale, but you don't have to be.
With Azure, and this is something that I wasn't working in it at the time, so I don't know the details, but the front door outage affected everyone within Azure.
Oh yeah.
But that is outside of your control, but is still within the cloud proper. It is a global service. Is there anything like that within AWS? So foundational and global.
DynamoDB. I said, yeah, it's a managed database service, but it's really one that all of the other services use at this point. It's like as much as S3 or maybe even more. Maybe it was 6 months or a year ago, they had a pretty baroque DNS issue where due to an issue in DynamoDB itself, which Route 53, their DNS resolver depends on, caused Route 53 to break, and then nothing could route back to DynamoDB to resolve DNS issues. And it was a clusterfuck because that broke so many services. I mean, things that were running really continued to be running, but anything that required like a configuration change was down. And as you can imagine, that breaks lots of workflows for lots of people.
It's going to be affected by DNS.
Yeah, it's
Good old DNS.
It's never DNS, but it's always DNS. There was, about 10 years ago, the northeast of the United States was without power. There was a fault in the grid. Many of the data centers went down for at least a few minutes until the backups kicked in. But that whole thing went on for several days, and there was some questions towards the end of could there be enough gas to keep the generators running? But when the electricity goes out, so many other things go with it.
yeah, it's again depending on how deep foundational goes, it's really worth calling out as far as an accountability sake, as you're saying, but also understanding what the problem is different from knowing that you're not going to be, you know, no one's going to put you down because of you know, something that is outside your control.
Exactly. You do get to say things are outside your control, which is pretty nice in a way.
Maybe we could do a round of applause.
Thanks. Sorry, yeah, and I would love to field any more cloud engineering questions. I know this thing was kind of broad because it's a very big
If you had to
area.
pick a cloud engineering service right now, what would it be? And what are all the options that you can think of?
Oh, god damn it.
Because there's AWS, Google, Superbase,
Vercel,
Cloudflare does a lot, maybe not everything.
GCP, OCI, Azure, Alibaba Cloud.
Yes, thank you, China.
Am I missing any?
I mean, if you're willing to count things like Superbase, it would